So we've got our data in L1. We've got the Core Plus kids without calculators in L2. We've got the control group without calculators in L3. So right now you're looking at the test that was given without being able to use these guys here. L4 and L5 are the frequencies of the Core Plus and traditional kids who were able to use calculators. So I'm assuming it's the same assessment, but with and without using machinery to see. Okay. So,
sorry, can you say what L4 and L5?
Absolutely, Laura. It's just the next two. If you look at your data sheet, if you keep going to the right, they were given some of the tests were given with calculators being allowed, and some with calculators not being allowed. So L4 is Core Plus using calculators, and then L5 is control using calculators.
Okay.
And that's a good question. Make sure we know where all the data is before we start futzing with it. Fair enough? So first things first. Suppose you are given this data, and you have to interpret based on this data and a good random sample. Let's assume it's a good random sample. I have no idea if it is or not. Let's assume it is. Who is doing better in both scenarios? So let's look at, and this is the way I like, the data I pulled gave me the data in this way. I don't know if the exact same assessment was given to the left group of data as the right. So let's keep them separated for the most part. If kids are not allowed to use calculators, the no calculators group that's right there, which ones are doing better? In other words, this data right here. That data right there. So here are the test scores. Here are the test scores. Here are the frequencies. Which group is doing better based off of not using calculators on the assessment? What do you think, based on those numbers? Scroll down to, oh, we're almost there. Which group of kids is doing better? Control or Core Plus? Core Plus, good. Anybody say control? Good. So there's some dissension. So what's one way to make this easier to see? Say that again. Oh, we can't do that, unfortunately. Damn. Damn, why can't we do that? That's a great idea, Drew. Why can't we do it?
You already have others.
If you subtracted L2 and L3, Drew, which I love doing, you'd be subtracting the frequencies, not the data itself. When you do the subtraction like you're talking about, which is a fantastic idea, you want to make sure you're subtracting data from data. You got to leave frequencies alone. Damn. Yeah, good idea, though. I love matched pair tests. I love them. I think they're fantastic, but we just can't use them here. Because we're not matching. These are totally independent data groups, so we can't match them up at all. What else can we do? Don't think 244, think 243. Suppose we're having a hard time looking at the data in this way. What can we do to make it easier to see? That's what I'm thinking. What kind of graph you want to go for, huh? Say that again. I wish we could. It's bivariate data. You'll get into scatter plots in your last project. Your very last project, which isn't due for 2 more weeks, deals with linear regression, which is when you actually have a data point that consists of 2 variables, x and y, and you'll scatter plot them up there. I would love to do that here because you have x's and y's, but there's no link between them. You'll notice on the scatter plots, I'll have you guys look at things like rate my professor ratings. Is there a tie between easiness and popularity? You're gonna analyze that and see, because each professor has one of those scores. They've got an easiness score and they've got a popularity score. What I did was I took a random sample of COCC professors, and we're gonna see if there's any kind of relationship there. But that's just the wrong kind of, there's only one data here, it's the test score. Thank you for that, that's great, Rachel. Isn't it great? There's always a tool to deal with the data. We just have to figure out which one we use right now. What do we do in 243? We wanted to see what something looked like. What kind of graphs do we use?
Histogram.
We use histograms, yeah, let's do that, let's do that. So I'm going to go stat plot. I'm going to turn 2 of them on. And we're going to do a little bit of finagling here. We're going to do a histogram and a histogram-y kind of thing. And that might sound kind of stupid, but we'll come back to why it's not necessarily. So plot 1, let's turn that histogram on. Now you got to make sure you get the X list and the frequency kind of dialed in here. Let's make plot 1 be the Core Plus kids. Their data is in L1, yes. Where are their frequencies if we're not using calculators? Go ahead, be brave.
Is it L2?
It's just L2 right now. Yes, it's just L2, yes. So if we've got a histogram on L1 and L2, and we do a zoom stat, assuming I got lots of stuff turned on. Oh, that's cool. That one I left from. Huh, that's like playing with my TI. Good for them. If you do a zoom 9 right now, there are the Core Plus kids scores. Fantastic. Fantastic. But it only partially helps me answer the question, yeah? the other part of the question is, what? Who am I comparing them to? Yeah, I gotta compare them to a control group. That's the whole point, is you have to see what the traditional kids did comparatively. Now, watch me do this and see why we're not all gonna do it. If I go down to plot 2 and turn plot 2 on, and make it a histogram, and set it up L1, L3, yeah, L1, L3, because I got the control group kids, and then I hit graph again, it's too hard to see because this is a feature the TI never worked out. They just graph everything on top of one another, which is annoying. I'd like to have them side by side or tilted, offset it some way. So there's one workaround for that. I'm going to have you guys decide which one you like best. One workaround is to change that plot type to this one here, which is almost a histogram, but it's a triangular histogram. It looks like this now. So that would be the Core Plus kids. I'm not a huge fan of that because the scales get bastardized. But here's another way that you can do it. We can ignore histograms altogether and use another graph form from 243 that doesn't overlay itself like this. What was another graph we used quite a bit in 243? Do you remember? Yes, the box of scatters. I didn't use it. I never even talked about scatter plots in 243. I saved it for 244. I know you did. I never did because I skipped that part of the first part. Like this is in a weird place. We'll put it at the end. So we don't see that here until 244. I'm saying if we change these both to box and whiskers with outliers, we kind of get a twofer. We get where the data is left to right, but we also get outliers if there are any. That's why I kind of like doing it this way. So I'm going to change that to a box plot, a modified box plot. Jack, what's on your mind, friend? Oh, okay, I couldn't tell if it was a question or just the thought coming. Or just it's 9 o'clock in the morning, it's hot as hell in this room. And then plot 2, same thing, but make it L1, L3. And then I'll just do a zoom 9. And what you'll see is, you'll see the 2 box plots. Now the only thing that the TI sucks a little bit at this is, I don't exactly know which one is which. Like I don't know which one is Core Plus and which one is Control. But if you press Trace, it'll put you on one of them. It's telling me that one up there, if you look at the top left, it says P1 colon L1 L2. That's plot 1 on list 1 and list 2, which means we know that is that's the first one, that's the Core Plus group. Which means this one down here is the Control group. Now, I like this a little more than the histograms. Because number 1, it doesn't overlay itself. Number 2, there's no intended or unintended bias by looking at 2 different kinds of graphs. That is a problem when you look at a dot connected with lines combined with a histogram, is that you get 2 different looks at something. The fact that the lines connected by dots are smaller in area than the bars might skew you to think one way or the other. This is great because both graphs are exactly the same. So friends, knowing that this is the Core Plus kids, and this is the Control Group kids, what's your gut feeling? What's your gut feeling?
Looks like Control is better.
Looks like Control maybe did better? Good? I mean, definitely on median. On median they're doing better, right? It's not something out here. On median they're higher. Look, Q1 in the Control Group is actually the median of the experimental group. That's kind of interesting. That means 75% of people of this sample, 75% of the sample in the Control Group did better than 50%, or the same as 50% in the lower group. That's kind of telling. There is some variation. I mean, definitely the mins and the maxes are very close. But we don't like making statistical claims based on just mins and maxes. Jack, what's on your mind? Go ahead. Oh, you just moved it again. I'm sorry.
My boxing was here.
We'll fix yours at the break. We're just about up to a break right now. So let's do this.
Never comes up.
Does anybody say, I heard a couple of claims saying it looks like Control's doing better. We can test that when we get back. Does anybody say there's no difference at all? That's a valid claim too. We can test them simultaneously. We can test that the Control group's doing better, and the alternative to that is that they're not doing better. You see what I'm saying? We can kind of test them at the same, and then the p-value tells us which one we should believe based on sample data. Let's take 5. It feels like there's no more heat pumping out of the heaters anymore. That makes me happy a little bit, yeah? It's cooling down a little bit. That's good. That's good. So, let's take 5.